Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC, this angle equals to 60 degrees, and we also know that BF equals to CF equals to DF, that equals to EF, and we also know that triangle BDF, this triangle equals to 8 square units. The area of triangle BDF is equal to 8 square units, and the area of triangle FEC, the area of this triangle is 15 square units, and we want to find out the area of the green shape ADEF. Okay, so first of all we will define angle ABC as B, and we will define angle ACB as C. We know that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in the big triangle ABC equals to 180 degrees. That is to say, this angle that equals to 60 degrees plus angle ABC that equals to B plus angle ACB that equals to C must be equal to 180 degrees. Okay, equation number 1 states that the sum of the angles in triangle ABC equals to 180 degrees. Here we will subtract from this equation number 1 60 degrees, and we will get that B plus C equals to 180 degrees minus 60 degrees is 120 degrees. Okay, so equation number 1 states that B plus C equals to 120 degrees. And we have rule number 1. Rule number 1 states that in front of equal sides in the triangle there are equal angles. In front of equal sides in the triangle there are equal angles. So I will read rule number 1 again. Rule number 1 states that in front of equal sides in the triangle there are equal angles. So actually in triangle BDF we know that BF equals to DF, and in front of side DF of triangle BDF we have angle B. In front of side BF we have angle BDF. So actually those two angles are located in front of equal sides in triangle BDF, therefore they are also equal to each other according to rule number 1. So in this, if this angle is B, then this angle also must be equal to B. Okay? Again, those two angles are equal to each other according to rule number 1 because they are located in front of equal sides. Therefore, if this angle is B, this angle must be also equal to B. And again, in triangle, we will repeat on the same process on triangle FEC. So in triangle FEC, we know that side FC of triangle FEC equals to side FE, and according to rule number 1, in front of equal sides in a triangle there are equal angles. So in front of side FE we have angle C, and in front of side FC we have angle FEC. Those two angles are located in front. Those two angles are located in front of equal sides, therefore they are equal to each other. So if this angle is C, then this angle must be also equal to C. Okay? In the next step we will define angle BFD as P, and we will define angle EFC as Q. Okay, and again we have rule, the rule that states that the sum of the angles in any triangle is equal to 180 degrees. So in triangle BDF, this triangle, we know that the sum of the angles in triangle BDF equals to 180 degrees, therefore B plus B plus P must be equal to 180 degrees. Again, in triangle BDF, this triangle, the sum of the angles must be equal to 180 degrees, that is to say 2B plus P must be equal to 180 degrees. Okay, so here we will subtract 2B from this equality, and we will get that P equals to 180 degrees minus 2B. Okay, angle P equals to 180 degrees minus 2B. And the same thing, it is true in triangle FEC. We know that the sum of the angles in triangle FEC must be equal to 180 degrees, therefore C plus Q must be equal to 180 degrees. Okay, again in triangle FEC, the sum of the angles must be equal to 180 degrees, therefore 2C plus Q must be equal to 180 degrees. We will subtract 2C from this equality and we will get that angle Q equals to 180 degrees minus 2C. Okay, we got that angle Q equals to 180 degrees minus 2C, and we've already found out that angle P equals to 180 degrees minus 2B. So here we will add Q to P. So Q plus P will be equal to 180 degrees plus 180 degrees is 360 degrees, and minus 2B plus minus 2C plus minus 2B is minus 2C minus 2B. Here we will take minus 2 as a common factor of this expression, and we will get that Q plus P equals to 360 degrees. Minus 2 is taken out as a common factor of this expression, and inside the brackets we will have B plus C. Okay, so we got that Q plus P equals to 360 degrees minus 2 times B plus C, but we have already found out in equation number 1 that B plus C equals to 120 degrees. So we will substitute B plus C in equation number 2 by 120 degrees, and we will get that Q plus P equals to 360 degrees minus 2 times B plus C is 120 degrees. Okay, so we got that Q plus P equals to 360 degrees minus 2 times 120 degrees. 2 times 120 degrees is 220 degrees, so I will write it down. So Q plus P equals to 360 degrees minus 2 times 120 degrees is minus 240 degrees. (360 degrees minus 240 degrees is 120 degrees. So we found out that Q plus P equals to 120 degrees, and we have already found out that B plus C also equal to 120 degrees. Okay, so in the next step we will find out the size of angle DFE, the size of this angle, according to a new rule, rule number 2. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 2 again. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. So actually we know that BC is one side of triangle ABC, therefore BC is a straight line. Okay, so BC is a straight line. BC is a straight line. Therefore, if we focus at point F, the sum of the angles at point F of the straight line BC must be equal to 180 degrees. Okay, we know that BC is a straight line. Therefore, the sum of the angles of the straight line BC at point F must be equal to 180 degrees according to rule number 2. So P plus Q plus the size of angle DFE must be equal to 180 degrees according to rule number 2. Again, P plus Q plus the size of angle DFE must be equal to 180 degrees according to rule number 2. But we have already found out that P plus Q equals to 120 degrees according to equation number 2. P plus Q equals to 120 degrees. So we can substitute P plus Q by 120 degrees in this equality, and we will get that 120 degrees plus angle DFE equals to 180 degrees. Here we will subtract 120 degrees from this equality, and we will get that angle DFE equals to 180 degrees minus 120 degrees equals to 60 degrees. Okay, so this angle DFE equals to 60 degrees. In the next step, we will join together points D and E by a straight line. We will focus on triangle DFE. So, in the great triangle DFE, it is given us in the question that DF equals to EF. Side DF of triangle DFE equals to side EF of triangle DFE. Okay, we know that DF equals to EF in triangle DFE, and we have rule number 1 that says that in front of equal sides in the triangle there are equal angles. So in front of EF we have angle FDE, and in front of DF we have angle FED. So actually those two angles are equal to each other according to rule number 1. Therefore, if we define one angle as y, then the other angle must be equal also to y, because those two angles are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees, so in triangle DFE, angle y plus angle y plus 60 degrees must be equal to 180 degrees. So 2y plus 60 degrees must be equal to 180 degrees. Here we will subtract 60 degrees from this equality and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. So here we will divide this equality by 2 in order to get the value of y, and we will get that y equals to 120 degrees over 2 is 60 degrees. So we found out that y equals to 60 degrees. So this angle equals to 60 degrees, and this angle that equals to y equals also to 60 degrees. So we actually found out that all the angles in triangle DFE are equal to 60 degrees. Therefore, triangle DFE is an equilateral triangle. That is to say, all its sides are equal to each other, so side DF equals to side EF equals to side DE. Actually, all the sides that I marked by two straight lines are equal to each other. So if side BF equals to X, then side FC must be also equals to X, and side FE equals to X, side DF also equals to X, and side DE also equals to X. Okay? So in the next step we will find out the sizes of angle ADE, this angle, and also the size of angle AED, this angle. Okay? According to the rule number 2, it states that the sum of the angles on a straight line is equal to 180 degrees. So we know that AB is one of triangles ABC sides, therefore AB is a straight line, and therefore the sum of the angles at point D on the straight line AB must be equal to 180 degrees. That is to say, angle B plus 60 degrees plus angle ADE, this angle, must be equal to 180 degrees according to rule number 2. Again, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. This states that the sum of the angles on the straight line must be equal to 180 degrees. Here we will subtract B and also 60 degrees from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, but we've already found out in equation number 1 that B plus C equals to 120 degrees. So here we'll subtract B from this equation number 1, and we will get that C equals to 120 degrees minus B. So 120 degrees minus b equals to c. So here we have 120 degrees minus b. According to equation number 1, it equals to c. Okay, so from this equality we can derive that angle ADE equals to C. Again, angle ADE equals to C. Okay. Okay, so angle ADE equals to C. We will repeat on the same process on the other side of triangle ABC. We know that AC is one of AC is one side of triangle ABC. Therefore, AC is a straight line, and we know that the sum of the angles on a straight line at any point on the straight line must be equal to 180 degrees. That is to say, angle C plus 60 degrees plus angle AED must be equal to 180 degrees. Okay, at the straight line AC, the sum of the angles equals to 180 degrees according to rule number 2. So C plus 60 degrees plus angle ADE must be equal to 180 degrees. Here we will subtract C and 60 degrees from this equality, and we will get that angle AED equals to 180 degrees minus 60 degrees is 120 degrees minus C. Okay, what we already found out that B plus C equals to 120 degrees according to equation number 1. So here we will subtract C from equation number 1, and we will get that B equals to 120 degrees minus C. Okay. Again, we found out that 120 degrees minus C equals to B according to equation number 1, so we can write here that 120 degrees minus C equals to B, and from this equality we can derive that angle AED equals to B. Angle AED equals to B. Okay, angle AED equals to B. So this angle AED equals to B. So in the next step we will focus on triangles ABC, the big triangle, and triangle ADE. Okay. So in triangles ABC, in triangle ADE, the green triangle ADE, the green small triangle, we know that angle AEB, this angle in triangle ADE equals to angle ABC in triangle ABC and both those two angles are equal to B. Okay? Okay, so those two angles are equal to each other and they're equal to B, and also we know that angle ADE in triangle ADE is equal to angle ACB in triangle ABC and both those two angles are equal to C. Okay, angle ADE in triangle ADE equals to angle ACB in triangle ABC, and both those two angles are equal to C. And this angle is a common angle, so angle A equals to angle A angle A equals to angle A. Actually, angle A belongs to both triangle ADE, and angle A also belongs to triangle ABC. So angle A equals to angle A. It is a common angle. It belongs to both triangles. Okay, so we found that three angles in triangle ABC are congruent to three angles in triangle ADE. Therefore, those two triangles are similar to each other, or triangle ABC is similar to triangle ADE according to angle similarity rule. Again, triangle ABC similar to triangle ADE according to angle similarity rule. Angle similarity rule states that if you have two triangles that all the angles of one triangle are congruent to all the angles of the other triangle, then those two triangles are similar to each other according to angle similarity rule. Okay, so in the next step I will present to you a new rule number 3, that relates to similar triangles. So according to rule number 3, the ratio between similar triangles is equal to the square ratio of the corresponding sides. So I'll read rule number 3 again. Rule number 3 states that the ratio between similar triangles is equal to the square ratio of the corresponding sides. Okay, so actually we will implement rule number 3 in our two similar triangles. According to rule number 3, the area of triangle ABC actually that is the sign for the area. This means the area of triangle ABC over the area of triangle ADE will be equal to the square ratio of their corresponding sides. That is to say, it will be equal to BC square over DE square. Okay, so actually that is the implementation of rule number 3 in our two similar triangles. The ratio between the areas of the two triangles equals to the square ratio of their corresponding sides. Okay, but what is the value of BC? BC equals to x plus x, that is to say BC equals to 2x, and BC square is 2x square over DE square is x square. So we got that it is the area of triangle ABC over the area of triangle AD equals to 2x square over x square. 2x square is 4x square, and 4x square over x square is 4. So here we got 4 of the area of triangle ABC over the area of triangle ADE equals to 4. Here we will multiply this equality by the area of triangle ADE, and we will get that the area of triangle ABC equals to 4 times the area of triangle ADE. Again, the area of triangle ABC equals to 4 times the area of triangle ADE. In the next step, we will find out the area of quadrilateral BDEC. So the area of quadrilateral BDEC will be equal to the area of the big triangle, triangle ABC, minus the area of triangle ADE, the green small triangle. Again, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. Okay, but we already found out that the area of triangle ABC equals to 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. Okay, so we do it now. We get that the area of quadrilateral BDEC equals to the area of triangle ABC is 4 times the area of triangle ADE minus the area of triangle ADE. So the area of quadrilateral BDEC the area of quadrilateral BDEC equals to 4 times the area of triangle ADE minus 1 times the area of triangle ADE is 3 times the area of triangle ADE. So we actually found out that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE, and the area of triangle ABC equals to 4 times the area of triangle ADE. Okay. In the next step, I will present to you a new formula for the area of any triangle. So, actually, if we have triangle ABC triangle ABC can be any triangle okay, so this is triangle ABC. We know that side AB of triangle ABC equals to 8 units, it's A units in its size, and side AC of triangle ABC equals to B units in its size, and the angle between side AB and side AC is theta. Then, according to the new rule, the area of this triangle, the area of triangle ABC, equals to A times B times sinus theta over 2. Okay, so that is the area of triangle ABC. It equals to A times B times sin theta over 2. Okay. We will implement this rule, this formula, in triangle EFC and triangle DBF. Actually, we will calculate the areas of those two triangles by this formula. So actually, if we divide the area of triangle EFC, that is 15 square units. If we divide it by the area of the small triangle, triangle DBF, that is 8 square units. So we get that 15 over 8, so 15 is the area of this triangle, triangle FEC, and the area of this triangle according to the formula that I presented to you will be equal to FE times FC so it is FE times FC times sine Q over 2. Okay, so the area of triangle EFC according to the new formula that I presented to you will be equal to FE times FC times sine Q over 2. And the area of the small triangle TBF, this triangle will be equal to DF times BF times sine P over 2. Okay, that is the area of triangle DBF, and that is the area of triangle EFC. Here we will move these two to the numerator and this expression to the denominator, and we'll get that 15 over 8 equals to 2 times FE times FC over 2 times DF times BF here we have sine Q, here we have sine P. Okay, so we got this equality. Here we have 2 over 2 is 1, so 2 is cancelled. So we got that 15 over 8 15 over 8 equals to FE equals to X, and FC also equals to X, so FE times FC is X times X, that is X squared. X squared times sine Q X squared times sine Q over DF times BF. DF equals to X and BF also equals to X, so X times X is X squared times sine P. So in total we got that 15 over 8 equals to x squared times sine q over x squared times sine p. So here x squared over x squared is 1, so x squared is cancelled. So we got that sine q over sine p equals to 15 over 8. Okay. Sine q over sine p equals to 15 over 8. But we have already found out that q plus p equals to 120 degrees. Question number 2. Here we will subtract p from equation number 2 and we will get that q equals to 120 degrees minus p. Okay. Okay, we know that q equals to 120 degrees minus p from equation number 2. So we can substitute q in this equality by 120 degrees minus p. Okay. So here in this equality sine q over sine p equals to 15 over 8. So sine q, we know that q equals to 120 degrees minus p, so we substitute q by 120 degrees minus p. We will get that sine, instead of q, we write down 120 degrees minus p over sine p sine 120 degrees minus p over sine p equals to 15 over 8. Okay, so actually here I substitute q by 120 degrees minus p. We got that sine 120 degrees minus p over sine p equals to 15 over 8. So here I will present to you a new trigonometric identity in order to find out the value of sine 120 degrees minus p. The trigonometric identity is that sine a minus b equals to sine a cosine b minus sine b cosine a. Okay, so we'll solve the value, we'll find out the value of sine 120 degrees minus p according to this trigonometric identity. So sine 120 degrees minus p will be equal to sine 120 degrees times cosine p minus sine p sine p times cosine 120 degrees. Okay, so sine 120 degrees minus p will be equal to sine 120 degrees is root 3 over 2 times cosine p and cosine 120 degrees is minus 1 over 2 times sine p. Okay, so here we have minus and minus is plus, so in total we will get that sine 120 degrees minus p equals to 3 over 2 sine 120 degrees minus p equals to root 3 over 2 times cosine p minus and minus is plus, so it is plus 1 over 2 times sine p. Okay, so we found out the value of sine 120 degrees minus p. Okay, so we will substitute sine 120 degrees minus p in this equality by this expression that equals to sine 120 degrees minus p, and we will get that root 3 over 2 times cosine p over sine p minus plus 1 over 2 times sine p over sine p. All equals to 15 over 8. Okay, so we substituted sine 120 degrees minus p in this equality by the value of sine 120 degrees minus p that we found, and we arrived to this equality. Here sine p over sine p is 1, so sine p is cancelled, and cosine p over sine p is cotangent p. So in total we will get that root 3 over 2 times cotangent p plus, instead of 1 over 2, we write down 4 over 8 equals to 15 over 8. We know that cotangles P have trigonometric identity that states that cotangles P equals to 1 over tangles P okay, we know that cotangles P equals to 1 over tangles P, so we will substitute cotangles P in this equality by 1 over tangles P, and we will get that root 3 over 2, instead of cotangles P we write down 1 over tangles P, plus 4 over 8 equals to 15 over 8. Here we will subtract 4 over 8 from this equality. Okay. Okay, so here we will subtract 4 over 8 from this equality, and we will get that root 3 over 2 times tangents P equals to 15 over 8 minus 4 over 8 is 11 over 8. Okay. We found out that root 3 over 2 times tangents P equals to 11 over 8. Here we will multiply this equality by tangents P, and we will get that root 3 over 2 equals to 11 over 8 times tangents P. So here we will multiply this equality by 8, and then we will divide it by 11 in order to get the value of tangents P. We will get that tangents P equals to root 3 over 2 times 8 over 11. Okay, so here 8 over 2 is 4. So we got that tangents P equals to 4 times root 3 over 11. Okay. We found out that tangents P equals to 4 times root 3 over 11. So actually, what is the function of tangents P? Tangents P actually express the relationship between the sides of a right triangle. So if we have a right triangle, so in this right triangle, we can express this equality by this drawing. So if in this right triangle, we know that this angle equals to 4 times root 3, and this side equals to 11, then tangent P will be equal to 4 times root 3 over 11. So actually this triangle expresses the fact that tangent P equals to 4 times root 3 over 11. And if we want to find the hypotenuse of this right triangle, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the square of the perpendicular. So the square of the hypotenuse will be equal to 11 square plus 4 times root 3 square uh, 4 times root 3 square. So 11 square plus 4 times root 3 square is the square of the hypotenuse, but we don't want the square of the hypotenuse but the hypotenuse itself, so we will take a root from the square of the hypotenuse in order to get the value of the hypotenuse itself. Okay, so that is the size of the hypotenuse. So 11 square is 121 plus 4 times root 3 square is 48, and 121 plus 48 is 169, and the root of 169 is 13. Okay, so the hypotenuse of this triangle equals to 13 units, and the sinus P will be equal to 4 times root 3, 4 times root 3 4 times root 3 over 13. Again, in this triangle that expresses exactly the fact that tangent P equals to 4 times root 3 over 11, we know that sine P equals to 4 times root 3 over 13. Again, we found out that sine P equals to 4 times root 3 over 13. And what is the area of triangle DBF? The area of triangle DBF, according to the formula that I presented to you, will be equal to x times x, that is x squared, times sine P over 2. Okay, so this is the area of triangle DFB. So here we will substitute sine P by 4 times root 3 over 13, and we also know that the area of triangle DBF equals to 8, so we can add here that is equal to 8 square units, and in the next step we will substitute sine P by 4 times root 3 over 13, and we will get that x squared over 2 times sine P is 4 times root 3 over 13, all equals to 8. Okay, so here 4 over 2 is 2. So in total we will get that root 3 . root 3 times 2 over 13 times x squared equals to 8. Here we will divide this equality by 2 and we will get that root 3 times x squared over 13 equals to 4. Okay, so we found out that root 3 times x squared over 13 equals to 4. Here we will multiply this equality by 13 and then we will divide it by root 3 in order to get the value of x squared. So we get that x squared equals to 13 times 4 is 52 over root 3. So we found out that x squared equals to 52 over root 3. Okay. In the next step we will find out the area of the equilateral triangle DFE. So the area of the equilateral triangle DFE will be equal to x times sine 60 over 2. X times x is x squared. Sine 60 is root 3 over 2 and root 3 over 2 over 2 is root 3 over 4. So we found out that the area of the equilateral triangle DFE equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3. So we can substitute x squared in this equality by 52 over root 3. And we will get that 52 over root 3 times root 3 over 4 equals to the area of triangle DFE. Okay. This is the area of triangle DFE. So root 3 over root 3 is 1 and 52 over 4 is 13. So we found out that the area of the equilateral triangle DFE equals to 13 square units. Okay. So the area of the equilateral triangle DFE equals to 13 square units. So actually now we can find out the area of quadrilateral BDEC. The area of quadrilateral BDEC will be equal to the area of triangle DBF, that is 8 square units, plus the area of the equilateral triangle DFE, that is 13 square units, plus the area of the big triangle FEC, that is 15 square units. So the area of the green shape will be equal to 8 plus 13 plus 15. 8 plus 13 is 21 and 21 plus 15 is 36. Okay, so we found out that the area of quadrilateral BDEC equals to 36 square units. Okay, but we have already found out that the area of quadrilateral BDEC is equal to 3 times the area of triangle ADE. Okay, and we also know that the area of triangle BDEC, we found out that it also equals to 36 square units. Okay, so from this equality we can derive that 36 equals to 3 times the area of triangle ADE, or 3 times the area of triangle ADE equals to 36 square units. Here we will divide this equality by 3 in order to get the value of the area of triangle ADE. The area of triangle ADE equals to 36 over 3 is 12 square units. Okay, so the area of triangle ADE equals to 12 square units, and the area of the green shape equals to the area of triangle DFE, that is 13 square units, plus the area of triangle ADE, that is 12 square units. Okay, so the area of the green shape ADEF the area of quadrilateral ADEF equals to the area of triangle ADE, that is 12 square units, plus the area of quadrilateral triangle DFE, that is 13 square units. So in total the area of the green shape equals to 12 plus 13, that is 25 square units. Okay, so we found out that the area of the green shape equals to 25 square units. Again, the area of this green shape, or the area of quadrilateral ADEF, equals to 25 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green shape, or the area of quadrilateral ADEF. Okay, and we know that angle BAC equals to 60 degrees, and we also know that BF equals to CF equals to DF equals to EF, and we also know that the area of triangle DBF is equal to 8 square units, and the area of triangle FEC equals to 15 square units. And we want to find out the area of the green shape, or the area of quadrilateral ADEF. Okay, so we know that the sum of the angles in any triangle equals to 180 degrees, and especially in triangle ABC, the sum of its angles is equal to 180 degrees. So we defined angle ABC as B and angle ACB as C, and we know that 60 degrees plus angle B plus angle C equals to 180 degrees. This is equation number 1. We subtracted 60 degrees from equation number 1, and we got that P plus C equals to 120 degrees, and then we have rule number 1 that states that in front of equal sides in the triangle there are equal angles. So actually in triangle DBF we know that BF equals to DF, and in front of DF we have angle B, so in front of BF we have angle BDF, and those two angles that are located in front of equal sides must be equal to each other. So if this angle is B, this angle must be equal also to B. And the same thing we can do on triangle EFC. We know that FC equals to FE, and in front of FC we have angle C, so in front of EF we have angle C, so in front of FC we have angle FEC, so those two angles must be equal to each other according to rule number 1. So if this angle is C, this angle also must be equal to C. Okay, then we defined angle DFB as P and angle EFC as Q. And again we know that the sum of the angles in any triangle equals to 180 degrees, and especially in triangle DBF the sum of the angles is equal to 180 degrees. Therefore B plus B plus P must be equal to 180 degrees, or 2B plus P equals to 180 degrees. And the same thing in triangle EFC, the sum of its angles equals to 180 degrees. So we will get that Q equals to 120 degrees minus 2P, and we have already found out that P equals to 120 degrees minus 2B, so we add Q to P, and we found out that Q plus P equals to 120 degrees, and we already found out that B plus C equals to 120 degrees. Then we have rule number 2 that states that the sum of the angles on a straight line is equal to 120 degrees, and we know that BC is a straight line, therefore Q plus P plus 60 degrees equals to 120 degrees. Okay, P plus Q plus angle DF equals to 180 degrees, and we know that P plus Q equals to 120 degrees, so we substitute P plus Q by 120 degrees in this equality, and we found out that the size of angle DFE is 60 degrees. The size of this angle is 60 degrees. Then we joined together points C and E by a straight line, and in triangle DFE we know that DF equals to EF. Therefore those two angles are equal to each other. So if one angle is Y, then the other angle must be equal to Y also. And we know that the sum of the angles in triangle DFE equals to 180 degrees. So that is to say 2y plus 60 degrees equals to 120 degrees. And we found out that y equals to 60 degrees. So this angle is 60 degrees and this angle is also 60 degrees. So triangle DFE is an equilateral triangle. Okay, then we found the sizes of those two angles according to the rule that states that the sum of the angles on a straight line equals to 120 degrees. So B plus C plus the size of this angle equals to 180 degrees. By solving this equality, we found out that this angle equals to C. And we also know that AC is a straight line, therefore C plus 60 degrees plus the size of this angle must be equal to 180 degrees according to rule number 2. And after solving this equality, we found out that this angle equals to B. Then we proved that triangle ABC is similar to triangle ADE because they have the same angles. Triangle ADE has angles 60 degrees C and B, and triangle ABC also has angles of 60 degrees B and C. So because of the fact that those two triangles are similar to each other, we have rule number 3 that states that the ratio between similar triangles is equal to the square ratio of the corresponding sides. That is to say, the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. And BC equals to 2x, DE equals to x, so we found out that the area of triangle ABC over the area of triangle ADE equals to 4, or the area of triangle ABC equals to 4 times the area of triangle ADE. So, and then we found out the area of quadrilateral ABDEC. The area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. So the area of triangle, or the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. We know that I presented to you new formula for the area of any triangle. The area of any triangle equals to A times B times sinus theta over 2. Then we have 15 over 8 is the relationship, the area of the big triangle over the area of the small triangle. So the area of the big triangle according to the formula that I presented to you equals to FE times FC times sinus theta over 2, and the area of the small triangle equals to DF times FB times sin P over 2. So we solved this equality and we found out that sin Q over sin P equals to 15 over 8. Then we know that Q plus P equals to 120 degrees, so in substitute we found out that Q equals to 120 degrees minus P. So we substituted Q by 120 degrees minus P, and we found out that tangent P equals to 4 times root 3 over 11, and sinus P equals to 4 times root 3 over 13. Okay, and the area of triangle DFB equals to x squared times sin P over 2. We substituted sin P by 4 times root 3 over 13, and we found out that x squared equals to x squared equals to 52 over root 3, and the area of the equilateral triangle DFE equals to x squared times root 3 over 4. We substituted x squared by 52 over root 3, and we found out that the area of the equilateral triangle DFE equals to 13 square units. After we found out that the area of the equilateral triangle DFE equals to 13 square units, we actually found that the area of quadrilateral BDEC equals to 36 square units, And we also know that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. So from this equality we derive that 3 times the area of triangle ADE equals to 36. We divided this equality by 3 and we found out that the area of triangle ADE equals to 12 square units. So the area of the green shape equals to the area of triangle ADE, that is 12 square units, plus the area of triangle BEF, that is 13 square units. So in total the area of the green shape equals to 12 plus 13, that is 25 square units. Okay, the area of the green shape equals to 25 square units. Okay, thank you very much.